Chapter 2.2, Speed, Distance and Time of the Year 9 and 10 Good Science textbook. Okay, let's start with this. Suppose I'm driving my car, my beautiful sports car, and I look down onto the dash and I'm going, for some reason, 100 k's an hour. On the freeway, of course, not in suburbia. Cough, cough. And I see this. What on earth does this mean? Well, breaking it up, it means I'm going at 100 kilometers per hour. We all know this. This is what goes through our heads, hopefully, when we're looking at this number. This means that I'm covering 100 k's, a distance of 100 k's in roughly 1 hour. There's no surprises there. So it turns out you can actually relate distance, time, and speed through a very simple formula. This is one of the simplest formulas in all of physics. Speed is distance over time. That's literally what I just read just now, 100 k's per hour. Hundred k's per hour. Right there. Speed is how much distance, or ground, same thing, you cover in a certain amount of time. The higher speed, the more distance you cover, right? Distance is the length between 2 points. And time, as we know, time is how long it takes you to do so. That's the formula. Now, sometimes speed is measured in units of kilometers per hour or meters per second. Now, you need to know how to go between these two units. In a previous video, I showed you this, and I'll do it again here. Think of stairs. A kilometer is bigger than a meter, right? If you think about it. To go from kilometers per hour to meters per second, so the conversion is, it's a number, and it's worth memorizing this number. Going up the stairs, think of multiplying your steps, right? You times by 3.6. Going down the stairs, you do the opposite of multiply, which is divide. You divide by 3.6. In other words, to go from meters per second to kilometers per hour, you times by a factor of 3.6. To go from kilometers per hour to meters per second, you divide by 3.6. These numbers, it's worth memorizing them. Let's do some examples, because after all, physics is about application, or motion in this case is about application. Suppose I'm traveling a distance of 50 k's in 2 hours. In 1 hour, let's say, to make it simple. What is my speed? Step 1, given. What are we given? We're given distance, 50 k's. So let's call that D. Remember, it's useful to call these by their appropriate letters, D. Time is 1 hour. T, 1 hour. How do we relate these two quantities? We know that speed is distance over time. Now, speed, we use the symbol V in physics. A textbook, okay, I'll use S actually. Sometimes in the textbook they'll have S. They usually use that for displacement, but anyway, that's something else. Speed is distance D over time T. For shorthand for this thing here. Speed is distance over time. Step 3, we sub and solve. S is D, D is 50 k's. T is time, 1 hour. Our speed is simply 50 k's per hour. That's it. Example 2. Suppose I'm moving 72 k's per hour. What is the speed in meters per second? This is a conversion question. I'd say multiple choice, so they would ask this. Okay, we need to go from k's per hour to meters per second. How do we do that? Draw the steps that I taught you before, that I showed you previously. Draw the steps, k's per hour, meters per second. Going up the stairs, you're multiplying your steps, right? So you times by 3.6. Going down the steps, you divide. Okay, think of divide as being going down, right? So we need to divide by 3.6. So we take 72 k's per hour, you divide it by 3.6, and you get an answer, punching this into your calculator, 20 meters per second. Okay, without writing another question, we'll do another one. Suppose I want to convert 30 meters per second to k's per hour. How would I do that? Back to the stairs, meters per second to k's per hour, I'll need to multiply by 3.6. Punching it into calculator, I get 108 kilometers per hour. And that's it really, speed is distance divided by time. That's that. There's a famous triangle as well. If you're a person who likes algebra, S equals D over T, you can rearrange it as follows. So T is just swapping these two things. That's the trick in maths. To get T the subject, you get D over S. To get D by itself, you multiply these two things. D is speed times time. That's for the mathematically inclined. For those who aren't mathematically inclined, draw a triangle. And this triangle works for F equals ma as well. As follows. Because speed is distance divided by time, speed is here. Distance at the top, time is at the bottom. You can swap these two as well. That's no problem. This line here is the multiply symbol. This line here is the divide symbol. So what you have to do to find S, let's say, just cover your cover S with your thumb or finger. You do D divided by T. Or to find T, let's say, cover it by using your finger. D divided by S. To find D, you cover your thumb, your finger with on D. T times S. So that's how that triangle works. And here's the same similar triangle for F equals ma. Okay, the same thing works. You can try this later. We'll do another example. One more. Example 3. If I'm traveling at 18 kilometers per hour for 4 hours, what is my distance covered? Step 1, given. We're given, let's dissect this thing. Speed, kilometers per hour, that's speed. S is 18 k's per hour. We're also given time, 4 hours. T is 4 hours, 4h. How do we relate these two things? We need speed is distance divided by time. Step 3, sub and solve. S is 18. D is unknown. We need to work out D. And T is 4. This is a matter of algebra. So D is just 18 times 4. Okay, to get D by itself, just times both sides by 4. Doing that, the 4's cancel, right? Because 4 divided by 4 is 1. So 4 times 18, your answer is 72 kilometers. Be very careful here. Because we've got kilometers per hour, k's is your unit of measurement for distance. And that's it. That's speed is distance over time. That's how you use the formula. And from here, it's just practicing really.